Alright, welcome to another video on the complete intro to SQL and Postgres as a way to update my knowledge base, especially for the Postgres version 14 and for newer versions like 15 and 16. So the whole point of today's video is to make a quick recap of what I have learned so far in this course, which is something that we began yesterday. In Here, this course is taught by Brian Hall, one of the front end master instructor. And here, yesterday we looked at a little bit of history of this introduction about what is this database, and especially what is this course is what who is this course for? Uh, yeah, to who is this course for, right? Because here we're gonna learn is well how to set up a Postgres database and tables, as well as how to think about the data filling, how to think about the data going through tables, as well as best way to write uh, queries for your application, identify and optimize slow queries, and then ultimately connect to SQL database. So, which means that this course is for developers, and the whole point of this is to look at how you can, with a very small subset of knowledge, you can do a lot of things, pretty much almost in Postgres. However, there are some other people that have decades in the industry that can do wild things, by the way. And even though the idea here is that this course is for developers, so this course is not for uh, DBA or for DevOps. Okay, so here we're not gonna see is, for example, things like replicate or deploy, or how to manage admin or particularly Postgres instance. So because of that, okay, it means that uh, this course is something very, very interesting as a developers, as a Node.js developers. And then we look at what are the things that we need to do, especially as a setup uh, the Postgres database or this course. We're gonna use Docker, and Docker is this way of how you can have a mini little OS running your application. Here we're also gonna use is the Docker image that Brian Hall actually create based on the Postgres 14. And here we have is couple database, for example, the movie database, which is something that we're gonna do as a way to look at how can we do this, and the Guru recipe, a Guru recipe, which is a database that we're gonna build along the way. And the step two actually started to work by, well, setting up your database uh, with Postgres using Docker. So we use first we pull the image, and then we run the instance, okay, by passing several flags to that. For example, here we're telling us that hey, this is the environment. Uh, Variables like Postgres password, the name of this container instance as a way to identify them, and this error indicates is that after you run all of these commands, hey, please get out of this inst, please clean up the console log, and after you uh, run the command, detach from that. All right, I don't want to be inside of the containers. Do that in this port, which is the default port for Postgres application, for database application using Postgres. So expose that, and we're gonna use is this instance for that, right? So this is the name of the image. What we're gonna do, and the subtle difference between the image and the uh, container is that image is like the recipe, the cookbook, whereas the container is in fact the dish already served, already prepared for. And there's also a side notes, especially for uh, things like background and foreground. So background is this concept that you have, especially on the background, okay, which is service that are running behind the scenes. Whereas with foreground, it's like applications that you're seeing that they show you the log in the case of Docker. So then I look at how you can now tell to Docker to execute a command on a container that has been run as a way to start to interact with that. In our case, with Postgres, okay, he would tell you, hey, please, I want you to execute this bash command with this username called Postgres, make it interactive, and then I want to now interact with the container name, the PG, by running this command, which is the client in SQL. PSQL is the client. So then we started to actually get our hands dirty, so do the work, which is by looking at the database and tables, and aware of database, which is since database it follows this particular standard, okay? And you may wonder, well, because uh, Docker has several changes, and each one of those versions change a lot every time they release new ones. How can we make sure, or how can we know what change will be? Or how can we make predictable the change that they're going to include in newer versions, right? So first thing first, a word of Postgres and SQL. So SQL is this standard that comes from ISO, okay, International Standard Organization. Very, very interesting. Pretty much like JavaScript, which follow is the ECMA 262 specification, and things like SQL, the SQL servers, MySQL, MariaDB, IBM, IBM, IBM DB, or Postgres, okay, all of them, you can think of them as like the environment of JavaScript, okay. So another example is see, because the SQL is the recipe cookbook, all right. All of this all of this thing that I mentioned, Postgres, MariaDB, SQL servers, IBM DB, all of them are the kitchen fully stocked, so ready for cooking, right? So it contains all of these tools and things that make your life much more easy when it comes to actually cooking, and when it comes to actually querying the data, creating database and tables, uh, creating your queries, identify and optimize slow query. So that's very, very interesting. All of these techniques that you can do. Uh, and that was very, very interesting. For example, in the case of JavaScript, because JavaScript runtime has not only the browser, but also Node and Dino and Rhino, as well as JavaScript, a lightweight engine runtime for the IoT. So you can see all of this is something very, 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 very important. And one of the things that Postgres comes is that also in each version it introduces new change for that. So as you keep, because Postgres, MariaSQL, MariaSQL because Postgres, MariaDB, MySQL, SQL Server, each one of them has their own flavor, has their own approach to solve a problem, has their own approach and tool to solve problems. But the reason why we're looking at Postgres is because also Brian Holtz, which is this software engineer that worked previously at Reddit, and also as Stripe and Netflix, he mentioned that Postgres is now leading the way in this industry. Uh, so the reason here, or how you can keep up the pace with the news and coming event, is by look at what is this particular version is doing, and then you can look at the change log. So recognize that each one of those engines or database management systems has their own flavor, have their own approach and tool for that. And now how Postgres has leading the way of this engine. So that's interesting. That's interesting as a way to have now a more holistic approach. And when you now interact with the PostgreSQL or Postgres server, you have a client, okay, in the server that this will act as a set of folders. So you can think of the database here as a set of folders in this context. So PSQL is the way of how you can talk to the server, okay, as a way to explore your data, execute a bash command, list your data, or list your database. What are the database that are behind here? Change between database as well. And then we started to look at now how can we create a table, okay? And especially here on Postgres, it's important to any keyword related uh, to the client, to the Postgres here in this case. Uh, it'll be as uppercase, whereas user information is in lowercase. So as you're creating now your first table, okay, where you identify is create table as a way to make sense and the feeling of how you can create that table is that you create a table and then the ID, where you're going to identify is the data type, as well as several other constraints. So integer, primary key, as well as the title and varchar, unique and not null. You may wonder that what happens if you add in a column, because after all, a table is pretty much like a spreadsheet. You can also even create a spreadsheet. You can also have a database in Google Spreadsheet. Not recommended, but it's possible. So this is this table, all right? And when you each one of those columns will be each one of those line here. Okay, so what happens when you need to add a column that is not null? All right, what will be the value by default that you have to allow it add it? Okay, uh, and that is when you started to see things like alter keyword as a way to batch or as a way to pass several instructions, several transactions. Mm, Now this has an holistic view to say, hey, I'm gonna return true, or I'm gonna give you a success, a thumbs up, when everything went well after I done all of this set of instructions. So for example, in our case, not only for adding columns or drop columns, okay, but also as you can see here is that is for other uh, modification that you want to do in your table. So this is something powerful because it can guarantee you to the transactions that it's going to be, especially if you need to make change in production, which is something that you have to do, all right? If you have to make change in productions, how are you gonna do about this change, right? And if you want to all of those things pass, not some of them and others don't. No, you want to do it or not. You don't you don't want impartially work. So all right, that was very interesting. Okay, and also how you can now read your data using, for example, select. Okay, my question is that after I look at this, what will be next? Okay, especially if you want to adding chunk of value. Okay, for example, here. For example, here. So that's exactly what I'm gonna do. You're not able to see what I'm gonna look because I'm looking is at the Brian Hold course, and I don't want to receive any strike for that. Okay, so we're gonna jump straight forward to the SQL command. Here we go. Okay, as we're gonna see how to insert multiple data here like that. Okay. The hell is even this? Okay, there we got it. Awesome. SQL command, SQL command. Exactly. And here is insert data and managing conflict. Interesting. Insert data and managing conflict. All right, here we go. Let's get ready. Let's get ready. Okay. We are we are going to see how to handle more data in more data going in and out of our Postgres. Okay. Okay. As a way to just recap this kind of thing. Okay. As a way to insert data, insert into the name of the database, in our case, ingredients, as a way that you can have the feeling of how you actually is going to do this kind of thing. And then we're going is to, okay, with the order of title, yeah, with the order of title, image, and types. Okay, the order here doesn't matter, but for consistency, yes. So the order here doesn't matter. Okay, doesn't matter. But for consistency, we we do. We're gonna do that. Okay, such as this. There you go. Doo, doo, doo. Okie dokie. And this will be quite annoying. Values, values. hmm And then you say, because this is one row, we say with single column, with single quotes, is red pepper. This is interesting of how they call that red pepper. Uh, red pepper.gpg, right? So red pepper.gpg as well as vegetable, vegetable, right? Awesome. And here we got. We say this, and then we got it here. We already insert that as it is. So no problem. No problem at all. By the way, first of all, you need to receive is the confirmation from the database. hmm So you can see this can become quite tedious pretty fast. Okay. Insert 0 indicates success. Success. Success operation. Okay. And 1 indicates the number of elements. And this is so simple. So simple. that look at what are the things that we can build with this. So for example, the banking system. Jesus. The zero means we didn't update anything. All we did was insert. Okay. The zero indicates. Okay. The zero indicates we add, we insert an element. Okay. The zero indicates we insert an element not updated. Okay. Interesting. Insert in Postgres. Okay. Yeah, that's right. But I think here the version really matters. So let me go to 14, which is this. Insert, create new rows in a table. As you can see here, all the things that you can do. We start simple. We start very, 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 very simple. The description, the parameter, with query, table, alias. As you can see, all of this sequence, SQL, all right, insert into table as alias, all right, and this is the column name for that. You can pass also other configuration like overriding system user value, default values, all right, like this, uh, as followed by the query, interesting, on conflicts and returning, right? Okie dokie. So where conflict target can be one of index column, index expression, collate, something that I want to see that later. But the whole point of this is that makes yourself familiar by reading the documentation here. But get yourself familiar with this. The output, OID, and the count. The count is the number of row inserted or updated. OID is always zero. It is used to be the OD assigned to the inserted row. If count was exactly 1 and the target was declared with EOD and 0 otherwise, but creating a table with EOD is not supported anymore. If the insert command return contains a returning clause, exactly, if the insert command contains a returning clause, the result will be similar to that of select statement, contained in the columns and value defined in the returning list. Computed over the rows, inserted or updated by the command. Notes, if the specified table is partitioned here, and this is just a couple examples here for that. Again, the idea here is to the idea here is to make yourself familiar of what you can do with this, because after all, this is the basics of uh, now interact with the database. Okay, so this is the basic of interacting with the database. All right, cool, cool, cool. So move on.
99% of what inserting is into. You see insert into, you tell it the table, you tell it the order that you're going to give it things, and then you give it the values.
That's all. That's what 99% of the table.
You can reorganize that. There's no sacred order here. So look at that.
Mm-hmm. There's no sacred order here. As you can see, there is no secret order when inserting elements. Okay, so by so there's no secret element by inserting when inserting elements. All right, that makes a lot of sense. Okay,
Image first, as long as I put replicate.jpg.
let me do something here. Let me make it more comfortable for myself. Oh, yeah, it is. Oh my God, yes. Ooh, that's right. That's right.
That is 99% of what inserting is into. You see insert into.
Exactly. So, so this is what 99% of what insert is doing, allegedly. Perhaps you're, uh, perhaps you are hiding some secret sauce. Is doing, which is inserting elements. You tell it the table. Mm-hmm. So you tell, you tell the table the order you want to add elements,
And then you give it the values.
and then you give them the values. Pretty much that's exactly what an insert is doing here in SQL. So this is insert. Okay. So insert, after all, that's exactly what it's doing. So insert is all about tell your table the order of elements you want to add, tell them, tell, then give them, then give them the values. Pretty much that's all. That's all. Yep. In Postgres, that's the whole point of this. In Postgres, that's all it is. Mm-hmm.
Yeah. So let's talk just a moment about single quotes, double quotes. This was confusing for me as a JavaScript developer where it makes literally no difference, right? It does make a difference when it comes to SQL.
Ding ding. You're in a different language, a different convention. Single quote here makes a difference.
So let's do this again. We're going to say insert into ingredients. Here, we can use double quotes. So I can say title in double quotes. I can say image in double quotes. And I can leave it off or type if I feel like, right? This is letting it know it's the actual name of the column, right? So I could even put ingredients in anyway, you can put ingredients in quotes as well, because I mean the table, right? So it's the identifiers that you can put into the double quotes. But notice here I'm doing it, here I'm not. It's optional. And frequently I don't. Almost never do I. And then here, again, because it's actual the literal value that I'm putting in here,
Mm-hmm.
I have to use single quotes.
Okay. So the double quote is indicating it's the name of the column. You don't use it, but when it comes to the value, you use single quote.
So
Okay.
another thing to note here is that um, white space is not significant. Notice I'm just putting things on new lines, and I'm putting. If you read my notes, there's tabs everywhere. White space is not significant. SQL, you can put infinite spacing. It doesn't matter.
Since type is a keyword, is there an issue having that as a column name?
That's a good question. Since type is a keyword, like you'll notice in my some of my highlighting, it'll show up as highlighted. It's not right. Like you can see here in this particular case, there are things I think that are off limits for column names, but I think most of it is pretty fair game because it's usually unambiguous in the grammar of SQL. But yeah, people, I'm sure someone might take exception that I called it type, but I've called lots of stuff type in my career, so but yeah. So that's a good question.
Yeah, no.
It's just for
No, it's just for
strings.
string. Completely.
So if I wanted to put like five there, I would put the actual number five. Because if you put a quotes around it, you can just that's a good thing to know. To do comments in SQL.
So, the TLDR of this is like um, single quote here makes a difference. It is used for indicate the order of which you want to add. So double quote. So you can use double quote since it is used to indicate the order in which you want to add. Okay. But when it comes to the actual value, but for the actual value, okay, only for strings, which is the vast majority of data that type that we're gonna use, only for string, we use is single quotes, right? Yep, pretty much that.
Well, so this will actually fail because we have a unique constraint. But notice
Types, notice the here.
here I have the dash dash here. This is how you do comments in SQL is the dash dash. Anything that comes after the dash dash is commenting.
Interesting. Comments, dash dash. Okay, comments. Interesting. So anything after the dash dash, double dash is a comment.
Again here, right?
This will fail because you have the same ID, which is primary key, title, and you are adding the title that
This will
contains.
fail, right? Because it's going to say this title key here, broccoli. You put a unique constraint on that so that the title is unique for that particular table.
That makes a lot of sense completely. So you take a look at this, And then when you say, hey, I want you to now add is, holy hell. This is the way how you adding comments here. I want to say he's like, this is interesting because this particular way of writing queries is something that is very, very in demand as a way to identify and optimize slow query. That's where the value of this thing is. So you say insert into ingredients. Okay. You can use this a quote, double quote here, something that you barely use that. And then after the parentheses, you make a space to indicate is the order in which you want to add all of this. Row title. As you can see, I'm using here double quotes as a way to identify is the name of this um, row that I want to add, or as a way to identify is the column name of this single, or all of the row that I'm going to add, whether it's just only one or multiple. Title, image, completely image. You can even leave that like that without that. And then after the double dash, you notice here, okay, notice the here. Okay, this is also interesting because it doesn't here after this uh, is they adding a new line and is here when he closes this. All right, this line, this sequence of instruction that you're telling to the machine. Okay, so you got values. All right, yeah, so you got values, and then you have is now the actual values that you want to insert here, which is in okay. We use single quote for strings. So broccoli like that. Broccoli.png. Okay, broccoli.png, as well as the type, which is a vegetable. Vegetable. Okay, and anything that is after the dash, which is a comment, you say and the here. All right, and then as a way to finalize this instruction, you hit a new line and then you do this. As you can see, this is the particular technique of how the adding is this query. That's interesting to me because this is something that I can also use, especially when I have to write my own queries on the, which is something that you don't want to, by the way. Oh no no no! It's something that you don't want. You might want to use this some ORM for that. Okay, that actually help you to simplify the for simple queries. Okay, which is crew operations. For simple queries, yes, but for sophisticated query, all right. This one, this won't be added. This won't be inserted. Uh, that's pretty fucking interesting. Oh, okay, because okay. But it seems like I added. If I'm going to add this again, I didn't set the constraint. Yeah, I didn't set the constraint of the title here. Yeah, I didn't set a constraint on the title. Okay, I didn't set a constraint on the title. Yeah, I didn't set a constraint on the title. However, if you, for example, alter now adding this chunk of it says column image on relation already exists. But if you want to do something like here, for example, That to me is something interesting because if do backslash D and then I hit the uh, backslash dish of this ingredient as a way to look at the property of that, this is something that was assigned by default. You know what it means? You assign this as default. Default generally always as an identity. And here you can look at this type already varying. It arbitrarily add that 50 not null vegetable character varying. So that's something very very interesting to consider because when you're altering is the table here, there's a way to do this and then move on to say, hey, uh, already exists, and that to me is something interesting because when I adding is uh, a broccoli, there's a way to look at what is this data have to. Okay, as a way, what is this data have to? List table, list database, execute, change. Okay, as a way to know what this data have to is the select from the query, which is the ingredient. Okay, and it tells me that it has is this. Okay, so if I now add this, it will tell me, hey, this key already exists in our database. Makes a lot of sense.
So it failed to insert that because I tried to insert it. It's already. One of the things I like about Postgres is I think it has for the most part pretty useful errors, right? Key title equals broccoli already exists. That lets me know right away you violated the constraint around.
So for example, in here, so if you violate a constraint such as this, mhm, what the hell? So if you validate a constraint by adding, if you validate if you validate a constraint such as this, for example, if you adding is this twice, such as adding broccoli twice, it will throw you error for that.
Unique titles. You can name these ingredients titles too. So if I say this dash D, you can see, or maybe here if I do ingredients, you can see that this has an index on the title key. We'll talk about indexes in a bit, but you can actually name these whatever you want. But if you don't name them, it has really useful same default names for them. So I generally don't name them because I like the names to be be typing out those things anyway, so I just let them be in the form.
But this is something that is generated for us. Ingredient title for this unique constraint. Exactly, the indexes.
But if you see key, that's another common one you see here, stands for primary.
Are tables stored like B trees?
Our tables are not stored as B trees. Indexes are stored as B trees sometimes.
Hmm. Good question. Very, very good question. Uh, our tables are stored as tree. Mm-hmm. No, they're not. Index sometimes are stored as tree. Tables does not. Hmm. And here, when you started to see, is one of the reasons why you have to create an index for them,
Uh,
and they're stored as B trees, binary tree or B tree.
we will talk about that when we get to indexes.
Hmm.
The actual physical manifestation of how Postgres stores them, I actually don't know, but it would not be true. So I want to put a bunch of stuff in our table, and I don't want to type it all out. So you and I are going to copy this query right here.
God damn.
Okay, feel free to copy and paste too much typing.
Jesus. But as you can see here,
Texts in here. You might get a little mangled because it might be too long for you
but
to
as you can see
type
here,
this.
followed
That's
by
fine.
the
This is
documentation,
terminals that we
okay,
enter.
and conflict is one of them,
Save correctly.
you know, as you can
Conflict is just
see,
here's one you can see here with this comma separating all these values out, right?
but as you can see here, okay, by looking now at the documentation here, it's like this insert operation, which is pretty simple, the base, the fundamental of this, okay, it's pretty much like you have the pepper or any of these single ingredients as a way to prepare your pizza. Okay, so insert is like this pepper, okay, the pepperoni. And when you do that, it's like, okay, that's interesting. This insert, okay, so you can tell here, hey, let's going to insert this. Let me insert in this table uh, with the order, okay, with the order all of these values, okay. So hey, I want to tell, I here I'm telling to the table, hey, insert, here I'm telling to the table, with this order, insert all of these values. There is no secret order here to do this, but for readability, it actually makes much more sense for that. As you can see here, there also another clause or another um, statement that is going to analyze, where conflict target can be one of, and conflict action is one of the do nothing or do update set. So the thing is that after you insert or after you tell PSQL, hey, I want you to now insert, I want you to tell to the client, hey, I want you to create a new row in a table. Before that, you tell to the table, I want you to insert this in this order, followed by the values here, all right? And then you have other statements that you want to analyze. Where, for example, where a conflict can be one of them, or in a conflict is one of them. So that's one of the reasons why we look in our case the do nothing. Okay, on conflict, do nothing. So as you can see, we have is avocado, banana, black pepper. Here, all of them is one single quote not double quote, because single quote indicates values. Okay. Uh, and let me see what Ryan Hall is gonna say about it.
But the interesting thing here is on conflict do nothing. Oh, it's good over here. It's quite easy to see. I had, for example, broccoli was in there already, and red pepper was in there already, right? That would have been a conflict. It's like, hey, you're trying to insert the title key again here. So basically, on conflict do nothing is saying if you hit any of these rows that you won't let me insert, just drop it. I don't care. Just keep going, right? So I could actually potentially just run this again, and it's going to insert 0, but it's not going to crash, right? Whereas if I did it again and I delete the on conflict part, and I just, I don't, is that correct? No, it's not. Eh. So we're just going to copy and paste to here. You can always hit Control C, and that'll escape whatever query you're in the middle of. Now I do that again. So because
Exactly.
I didn't put the on conflict do nothing here, it's going to immediately fail, and then nothing gets inserted, right? So that's part
Hmm.
of what to do on conflicts. It's good if you're doing like massive inserts.
Okay. Completely, man. So on conflict. So on conflict. So as you can see here, all right, in our conflict is like, so uh, making massive, okay, making massive insert with constraint, with constraint, do nothing, okay, with constraints like do nothing, okay, that's interesting. Make massive insert with constraint, do nothing, insert into ingredients, title, image, and types. So you can see here, as you as you can see here, on conflict, which is part of the anatomy of the insert, do nothing. Okay, as you can see here, on conflict, which is part of the anatomy of the query. Okay, do nothing. It means that whoever is violating, whoever value is violating a constraint, or for example, you want to do you want to insert massive data, you want to insert massive data, uh, massive duplicate data, uh, don't do nothing. Okay, don't do nothing when that happens, and follow along. Don't throw any errors, and that's great, man. And that's completely great. It's like move on, man. Move on. You can also define some other constraint, but this constraint is like mm-hmm, mm-hmm.
It's database with a bunch of information to give it those kind of on conflict things. Otherwise, if you have one error, So I just wanted to show you a different way of, or something else you can do with that on conflict. If I say insert into ingredients, and I say title value,
Mm-hmm. Part of the order,
values,
and then add in this values, which is single quote.
you can see there that watermelon definitely already exists,
Mm-hmm.
and I want to give it the image of banana because I don't live by the rules.
I don't live by the
And
rules.
I can say something of the type here, but I can just say this won't be updated. So you might wonder, why am I putting two quotes there? This is how you escape
Mm-hmm.
single quotes inside of the values, right? Because we can only use single quotes, we need some way of saying, like, what happens if I actually want a single quote inside of my query? The way you do that is found with backslash, which is what I was used to with literally everything else in SQL. It's you put two single quotes next to each other.
As a way
Okay,
to escape
so
character. As a way to escape character. That's also very nifty. And as a way to escape character, we use is as a way to escape character when adding values, we use is the single quote, the single quote to do that. For example, I don't think you have that. Okay. For example, here. Yeah, for example, here. By doing the double escape, by doing the by using the escape character, by using is the single quote twice.
won't work, right? I can actually just run it as is, and it's going to say, well, I didn't put, it's not valid, it's type. Okay, you can't put watermelon in here. I already have a watermelon. Heck off. I'm not going to allow you to do this. What if I want to say, if this doesn't exist, insert it. If it does exist, update it, right? So watermelon exists. What if I just want to update it? This
Do
is
you
where
have that constraint?
conflict comes in or is helpful again. On conflict, you have to tell it on what sort of conflict, in this case, title.
Okay.
Then you're going to say do update set
Mm-hmm.
equals excluded dot image.
Do update set image equal to excluded that image.
So imagine if I have 50 of these, right? And I wanted to just update it if it has some kind of conflict there. That's what the excluded dot image is. The excluded means the row that got excluded, and then I want you to pull the image off, and I want you to set the image on whatever one that commented on title.
Oh, so if you want to actually, if you find any conflict, and on the title here, do update set the image
So
for
that's
that.
actually my point for you.
But again,
Just a second. So let's start from ingredients.
exactly.
Here, title equals watermelon. You can see there it did update it. I don't have two rows in here. I have just one, and one got
Mm-hmm.
updated. You will typically we hear this referred to as an upsert. To update or
Mm,
insert one step.
is updating and okay. This is operation. It refers to that. Okay. 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 This is something interesting. All of these little details because oh my god. Uh-huh. So thing is when okay. This is when grow up men actually do this. This is when grow up men actually grown men and women do actually do this. It's like okay, so you have is this, okay, and on okay, all right. That's one of the reasons why I get it. Why a lot of these people, because you actually are learning is a new language, a new specification. That's one of the reasons why I get it. Why a lot of people that are using is ORM. It is pretty fucked up because at the end of the day you are going to end up writing your own queries. You shouldn't, you shouldn't, okay? But when the times comes, you want to know why you're doing that. So here, when you are inserting, okay, and if you want to do a massive insert, this is what you can do for that. All right? Okay. This is what you can do for that. All right. So is this. But as you can see, this following is the specification here. Okay. Hey, if you're doing massive insert, okay, massive inserts, uh, massive insert without any conflict. If you're doing massive insert without any conflict, okay, massive insert without conflict. Okay. Massive inserts without conflict. Exactly. Massive inserts without conflict. Or they do nothing. Okay. What you want to do now is observe. Okay. Which is this. So when you want to do observe. Okay. Observe. Or in other words, insert or update if that exists. Oh my god. Okay. Massive insert. Okay. Observe, insert or update if that exists is by doing this. Do update set that. But again, this is when you have to explicitly tell. This is when you have to explicitly, explicitly, exactly, explicitly tell. Okay, this is when you have to explicitly tell. Holy shit. This is when you have to explicitly tell uh, to the query which which column or which conflict in this case, which conflict, which conflict or when a conflict happen at a particular when a conflict happen on a particular column, do this, the set here. Oh shit. This can be quite annoying, bro. Because right now it's like, hmm, right now it's quite simple, you know? Right now it's quite simple.
One step. If you're doing something like MongoDB, you actually literally call it Upsert, right? It's even a method that you use. In SQL, you can use on conflict business.
Mm-hmm. Exactly. So MongoDB actually call this Upsert. Okay, that's one of the reasons why you have to look at this. This is a particular technique, my friend. This is the techniques that you're learning here. And the strategy is as a way to build these scalable applications. Scalable applications when you want is to actually query the data needed for this particular business. Okay, querying the data fast for this particular business use case. For example, give me all the transaction between uh, different between a buyer and a between a buyer and the seller. Okay, for example, mm-hmm. MongoDB actually called this Upsert. Holy shit! And and in Postgres we have is this do do update business. Oh my god. Upsert. So you have here now insert, okay, insert comment. Our table has stored as binary 3. Uh, no, but index, some of them sometimes are stored as binary 3. I get it why there is a lot of people actually looking for, hey man, you should know about this data structure. You know, you should know about this data structure as a way to build your applications. You know what I mean? Mm-hmm. Okay.
So if I come back and do this again, what happens?
Okay. So what you did is here insert. Okay, this is the table I want to. This is the table I want to insert these columns with these values. These rows columns with this value. This won't be updated. And then he said, no, I already updated. But if I want to do this again, all right, watermelon, banana, GPG. So if you want to do an observe, which is in this case, anytime you see this particularly way of doing this is like on conflict do update, okay, which is an observe, okay. Uh, now it's going to uh, update that value, observe.
You can also just say that this would just get set to some string as well, right?
And what you're gonna do is to set the image as the default
And now
GPU.
if I do this, let's say I had 500 conflicts, right? All of them would be set to default.jpg instead of actually going update.
That's something interesting because that excluded dot image, okay, will now the okay that excluded value will now be used as the observe.
And now if I do this,
Again, the whole point of this is to understand anytime when you actually tell JavaScript to write your own queries, it's like, oh, Okay, that makes a lot of sense.
Say I have 500
That
compliments,
makes a lot of sense of
so
what's going on here.
instead of actually going
God damn it, bitch. God damn it, bitch. Okay, so what we're doing is this basic stuff here.
updates and deletes. We saw an upsert.
Okay, updating and delete. Okay, updating and delete. And here we are. Holy F. So, updating and delete. Deleting. Updating and deleting data. Deleting data. But as you can see here, what we're doing is actually take a look at the crew operations that the vast majority of web applications are doing, but now at the database level. Okay, at the way of how you can, at the way or at the level you want to persist the state of your application. Because you can do that on Node, uh, because that actually you can share data across different threads, because this is actually anytime you create a node application mount on each one of those processes as a way to bring the community to think about in one single thread, which is that's something great uh, that Ryan Dahl actually make as a way to make our lives much more simpler. Okay, and with that, so now what we're doing is that how you can do these screw operations that most of the time you rely on an ORM, and the ORM actually abstract a lot of this nifty little details, all right, from you. I mean, again, that's great up to a certain point, but you actually need to understand where these things are coming from. Why? Because when you need to actually write queries in production or some way to dump data, okay, you need actually is not only know what this query is doing, okay, what this statement is doing, but also uh, if you want to actually automate all of those processes, you know what to do. So this, as you can see, is looking at how in this lower level you are doing the things on foot, right? So you don't have a bicycle, you don't have a motorcycle, you don't have this abstraction that actually makes things much more faster. No, 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 no. You are doing things, you are looking how these things are being done behind the scenes. And out there, there is a lot of applications, there's a lot of people that might have their data not sorted well. They might have that. They definitely might have that. Okay, that's interesting. That one. Yep. Yep. Okay. Insert massive inserts on conflict. And again, I don't want to memorize this, and I don't need to memorize all of this concept. What I need to understand is that what are the things that I need to do? What are the things that I need to do for the business? Okay, for the people. That's the only thing that I care about. It. So what are the things that I need to do for the people? And then overly focus on that. Because at the end of the day, that's exactly what they want. Okay? Understand their needs. And all of the whole thing of doing this is like that. It's like understand that. hmm Okay. That's very, very interesting. Yep. That's very, 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 very interesting, by the way.
¿Qué onda, perrillo? Buenos días, ¿cómo estás? No, marico, al revés. Nos vemos en Ciudadela, que me tires en caballito. Porque yo igual tengo que salir desde donde esté a Ciudadela con la moto. Y ahí la transfiero y bueno, me quedo a pie. Rescátame si puedes. Si no, no pasa nada, marico, agarra un taxi. Está bien.
So now I'm getting all of this, especially tactics, techniques of this. All right. So you have insert, you have massive insert, and that's the way how you do this. And the idea here is that you're starting to get familiar with this particular tool. Okay, insert, massive inserts, um, massive insert without a conflict. That makes sense. When I saw this, when I saw the first time, to me was like very, very, very hard. Very, it was not hard, man. It's because I wasn't dedicating my time and energy and attention to that. That's all. I wasn't there, and not even I wasn't there. It's like I don't even want to be there. Oh, that's what happened. So the only thing that you can control, okay? Yeah, totally. The only thing that you can control is now this moment. That's all. That's all. There's things that you can't control, okay? And that you have to let it go. Uh, and when it comes to actually things that you can control, do the work. It makes more sense. And I remember she explaining that, and to me that was I yeah, I don't remember her name, but it's like hmm, I wish her the best. She actually is part of the Meta team group there, but to me was like, oh my god, it's because perhaps her role as a woman in that industry, yeah. So it is funny because sometimes some women, hmm it is funny because sometimes women in the academy as well as gay people, they're more mature than than a lot of us. A lot of men, by the way, way much more mature. But they're not that wise in their decision making. But in any case, who am I to judge? And with that, and when I say decision making, is that perhaps in emotional, no one is like, to be to be honest. It's like no one is. We're just actually trying to figuring out that thing as we move on. So I get it, man. I totally get it. I totally get it. And even though I was distracted of the pain of life. Anyway, yeah, man. It's like, yeah, oh my God. Oh, thanks. Thanks, girl. Thanks. Completely. Completely, completely, completely. Yep. Okay. Totally. So, as we move on here, now looking at these particular techniques, now I understand them, motherfuckers. Like, oh, shit. Alright. Yeah, Jesus. What a painful learning experience all of this has been. Uh, a truly rewarding, truly marvelous. Okay, so as we move on here, by looking now at the SQL command insert, how you can do massive insert, okay, and actually how interesting is this because it's like pretty much uh, imagine that you are working, okay, imagine that you are working at Amazon garage warehouses, okay, imagine that you're working at Amazon warehouses, okay, and then they tell you, hey, you know what I would like you to do is this particular process. uh, yeah, I would like you to do this particular process, which is insert or adding all of this pile of boxes there as a way to store that. So the powerful thing of looking now at these databases, especially this SQL command, this specification of how you can is given a set of instructions as a way to store that data. on this particular machine on a Postgres server, it's like I don't know how physically it do that. All right, but what I can see here is that that's interesting in terms of how fast all of these operations can be done, bro. How fast is all of these things, for example, inserting all of this element here, inserts this batch of data, okay? And if there any conflict, move on, move on. You actually telling it's pretty much like you have a bot or someone here. Hey, insert me this batch of data here, and if there is any conflict, forget it, move on. All right. The other is uh, you can do single insert or you can do massive insert, something that is very, very powerful on at scale, at production. Okay, it's a way to dump the data. Uh, mhm. Right now, we're looking is more like insert. Okay, and then we also look at queries as a way to use select as a way to hey get me read this information from this, so access to this data and give it to me fast as possible. Okay, all right. So then we look at the Upsert, okay, which is hey, if you already find this element in this massive uh atom, okay, hey, I want you to insert this element. I want you to insert this huge of pile of boxes there, and if you find someone that exists, okay, or if you want someone that actually have the same label or the same unique label, I want you to now update the content with this new batch. All right. So, for example, let's say you have a pile of boxes, pile of um, Adidas boxes, right? And Nikes. You have a pile of Nike. You have a pile of Nike boxes organized, uh, let's say, per model, okay? And the size is 10, the US 10, all right? Foot size. Well, what you can do there is that if I'm gonna do all of this insert, okay? If I find someone that actually is the same model, okay? Uh, I want you to now update their it is content. So, for example, if the model that you have is something that is old, okay, 2019, okay, and this new batch is for 2014, I want you to update that, right? So the whatever is now, get out of it, remove it, whatever. I don't want that. hmm hmm You also want to keep track is all of these different chains that you are doing, migrations, when you mutate the scheme of your data. All right, here we are. Okay, let's go, bro. Let's go, man. Let's go, man. Let's go, man. Totally. Let's go, man. Oh my, yeah. Yeah, yeah, yeah. Let's go, man. Yeah, okay. Move on.
Let's just do a normal update now. So I'm going to say update ingredients set image equal to watermelon.jpg, or you can go back to, oh, we call it strawberry, I guess. .jpg, where title equals watermelon. You can see there it did an update. I say select star skin. If in case it's unclear, you can hit up. It'll scroll backwards through the queries that you've done before, which is what I'm doing.
So here we're doing is not an update here. What we're doing is this low level. Yeah, we're doing is this low level. Okay, we're doing is this low level operations, which is not do an update, right? Update on that particular table ingredients, and now here's different. Now the syntax here is different, so this is for insert. What is the next element here? I will argue that it will be is listen and listen to a notification. That's interesting. Okay. SQL command. Documentation here. 14. Preface, tutorial, SQL language, definition, data manipulation, data type, concurrency, server administration, uh, client interface, server programming, extending HTML trigger, PLG, procedure, reference, internals, internals. Native language support, writing foreign data wrapper, writing a table here, binary tree index, gist index, hash index. That's interesting. Depends. Exactly. Depends. PostgreSQL error code, datetime support, SQL keyword, SQL command. And what I want to know is the reference, convention, tutorial, SQL language. Okay, the syntax, but I'm more for the data definition. Oh, but this is for looking at. No, I'm looking more for the data definition. No, the SQL command, man. Okay, SQL command. There you got it. The reference. All right, makes sense. The reference. All right. As you can see here, you're now slowly to look at where you have to go on that board. Alter aggregate. Okay. All right. Alter. You can see all of the things you can do with alter, which is doing a lot of operation. Change, 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 change. Alter, alter type. Change the definition of a type. Analyze, begin, call, checkpoint, closer, cluster, commit, create, a collation, create an index, create. We also use so far is the create database. Okay, we create a table for create table. Anyway, it's just not here. I think this is organized by alphabetically. Yes, it is. Create create database, create table. That's right. And also create an drop. Then we jump to insert, and then we now look at the update. Okay. All right. And then this select retrieve route from a table of view. From a table or view, select into, define a new table from the result of a query, set change a runtime parameter, set constraint, okay, set change a runtime parameter. So you're gonna change this, okay, this parameter at runtime. Damn, son. Update set, you're doing that at runtime when actually it's doing that execution. All right. Okay. Now, interesting research. SQL command in Postgres, of course. So Postgres SQL command. All right. Okay. As a way to develop this intuition. Mm-hmm. Noise. So you can see here, we're going to update this element by using is the update table. Okay, so update the table. If you don't remember much of that, you can take a look at the here. When you take a look at this, update the table, and set means that I'm going to do this at runtime. I'm gonna change, you know, I'm gonna change a parameter at runtime. Change a runtime parameter or set. PostgreSQL version 8 through 8.2, the effect of a set local will be cancelled by releasing an early save point or by successful exit from PL-ESQ. As you can see here, this is also a job. Mm-hmm. Okay, this is also a job by itself. Set the schema path. Set the style data to traditional Postgres day before month input conversion. Set the time zone Berkeley, California. Set the time zone for Italy. Compatibility. But we were right now looking is at the update. Okay, okay, okay. Where update? There you go. Update here. Okay. Update you specify only this table as alias, and this is what you're going to change runtime parameter. Here you're going to specify is the number of columns to update. Okay, it can be this is an expression, or it can be as a row. All right, or it can be a sub select as well from items where conditions returning an expression as like that. So let's make it simple right now. Update ingredients. So hey, I want you to update now the table ingredients with set. Okay, set a particular column here with that property I want to, or that column name, because here they're using is the column name. With the column name, I want you to do this. All right, set image, and if I'm able to look at this, set image with a particular expression. Okay, how do you define expression here? Or an expression or a subtask. Okay, this column name where current where condition or where current of cursor name. Exactly, where condition where you're gonna update the ingredient set where mhm, where the condition in this case makes sense. Set this image. Okay, set the image value. Okay, set the image. Okay, that makes more sense. So set the image. Okay, of the ingredients. Set image as broccoli. I don't know what's the name of this. Banana, strawberry GPS, strawberry GPG is important the single quote here because it indicates this is a value. Okay, you're gonna set these values. You're gonna set this column. You're gonna you're gonna set this value on the column image where uh, where an expression, where the title, I think it is, or the title, yeah, where title, which is a column, where title is equal to broccoli or watermelon. So watermelon. And I'm gonna do is this. As you can see, it actually updates the number of rows here. Mm-hmm. 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 Update. Okay. So you're gonna now to do this update. Here is all of these several steps that is actually happening behind the scenes. Something that I'm quite familiar. I wasn't quite familiar with this. No, not at all. I'm not gonna lie. I wasn't that quite familiar with this. No, not at all. I wasn't quite familiar with this. Mm-hmm. I wasn't quite familiar with this. Yeah, I wasn't quite familiar with this. Totally, totally, totally. And yeah, but this is the manual step, the building block, especially when you on the server on the route handler, you say, hey, we need to update. This is all the thing that it's doing, especially if you're talking to a Postgres database. Oh, okay, you say, hey, what you're doing behind the scene is actually following its best practice as well. It's like, hey, update this table, uh, update this table, uh, yeah, update this table, uh, update, update the table, column name, uh, update this table, update the column name table by set, okay, update table set, okay, so update this table and then set the column, uh, and then set the column with this value where you find something. So when you find this particular expression, when this condition actually match, that's what you're gonna do here. Hmm.
So I've done this up.
And if you wanna know now is your uh, ingredient here, you wanna query that, select all of this from ingredients table, select all tables from ingredient tables, where which will indicate that this belongs to the SQL, where the the image is equal to the single quote is important strawberry dot gpg. And I need to pass is the semicolon here. It tells me, hey, no, I don't have anything like that. Oh, it wasn't able to actually update that. update ingredient set image strawberry.jpg where title is equal to watermelon. Strawberry JPG where title is equal to watermelon. But I don't think it is because we haven't updated watermelon or we haven't add watermelon to that. We insert watermelon, okay, and on conflict, which is the upsert here, on conflict do update set like this. And here's when you can now add update this. So by adding is this instruction, and here you say, hey, the exclude value dot image, you're going to assign that to the new value. Exactly. We already add that, and now you can see we are updating that. Holy moly! Ah, damn it.
Okay, here you just say set whatever do you want, and then you give it a where clause to define which one. If I didn't give it a where clause, it would update
It will update literally all image. Mm-hmm. Every single column with this.
every single one, right? Which is might be what you're trying to do, right? You might want literally everything to have a picture of a strawberry. You have a weird recipe, after my opinion, at that point, but
You have a weird recipe.
it's possible, right? What if you want to see what you're doing, right? And this actually works on the inserts. This works on the deletes. What if you want to see what the result of your works are after you've done them? So we can say update ingredients set.
Okay. Which is one element here. Updating and deleting. So updating one element here. Updating one element here. Okay. Otherwise, you will, otherwise, without the where clause, you will have, yep, updating one element here. Otherwise, without the where clause, you will have is the otherwise without the where clause, you will update, you will apply this to all rows. Might be the thing you want, but you will have a very weird recipe or a very weird ingredient table. It's like, okay, okay,
Image equal to watermelon.jpg.
exactly. It's like, what if you want to have now the view after you update something?
Where title equals watermelon. And then I'm going to say returning and you can just ask for whatever you want back, right? In this case, I want back the title, the image, and the ID and the type, right? So not only am I updating it, right? This is an update command, right? It's not a select command. But by saying returning this is like, hey, once you've done everything, give me back everything that you updated. I'm sure you can imagine this being useful. Like, let's say you're updating a user's profile. You want to confirm to the user, it's like, hey, you set your new picture and you told me that you now live in Minneapolis instead of Seattle. So I'm going to update the database and ask for the new information back so that I can send that back down to the user to confirm to them this stuff
To
actually
confirm
changed.
it, exactly.
So that's what the returning does. Now, just
Hmm. So in this case, it'll be is like, well, after you update that, returning returning is the type of this. Returning is a shape of it. So give me is the title, the type, in this order, by the way. The title, the image, the ID, and the type. And then give it to me. This won't be updated. Okay. Interesting. You have a type fruit. Hmm. Okay. Perhaps you update that. Alright.
this is kind of a burdensome thing to say. Let's say I
Maybe is because of this massive insertion. Maybe because of this massive insertion. What I do is this. What I'm doing is this. Then returning title, type, ID, title, type, ID, and what else? An image, title, image, and it says that type won't be updated for that because you say, hey, no, I don't have anything on this. The other thing is like, hey, if you have now this, okay, because now we're gonna do is um, if you have a conflict, yeah, on conflict with the title here, uh, do update. Do update is not only the image, but in this case is the type. As a way to say excluded type for this. Which means that now what we're doing is effectively is an upsert, a massive upsert. What we're doing here is a massive upsert. That's what we're doing here. Is a massive upsert. Okay. By doing is this. Exactly. Which means that once we say, hey, I want you to now give me is the so update the table ingredients, uh, update the table ingredients, and set the. I don't want to repeat myself by the way. Definitely don't want to repeat myself by the way. No, no. And set the image strawberry to this. All right. And then as a way to now is the returning values. Okay, returning is exactly. So returning is the shape of this data. So what is the column that you want to return here? Okay, I want to return is a type, and also the title. Let's start with title, type, and the ID. Okay, and the image. And please execute that. As you can see now with it on real time is an upsert. Okay, with it in real time is an upsert. But as you can see, any operation or any transaction that you do here, you have to have a backup plan. Oh shit. So that's one of the reasons why most of the time we care most about is, yeah, that's why most of the time we care most. Oh my god, that's one of the reasons why having this relational database can become quite a pain. Yeah, don't blame me. Can become quite a pain. Jesus fucking Christ. Because you need to know is the shape of this data. And you need to have that. You need to visualize this shit. Mhm. You need to visualize this shit, and this can be. I get it why you need to do migration. And when you mention migration, which is one of the tasks that you'll absolutely have to do anytime you change the schema of your database, or any exactly. For example, here, or any you want to do anyone you want to dump data. All right. So anytime you want to exactly. So anytime you want to dump data to create a migration, okay, or when you want to update the data, yeah, anytime you want to create a data, this is where the value comes from, not the front end, not the back end. It's like, man, you can set all of these things. Right now, it's like doing hand, yeah. Right now, it's like doing is this is like doing hot dogs, you know. This is like hot dogs. There's nothing wrong with that. But this, my friend, is where the value comes from here. It's a way of how you organize your data. It's a way of how you now, for example, make migration, which is something that can cause the most burden and the most downtime in companies. Because a lot of them, they don't know how to do this kind of thing. Because it's quite complex. And if you fucked up, well, you don't want to do that. A lot of these people is like, no, I want to do this integration and I can't think and blah blah and so on and so forth. Great, good. This is just like daily operations. Like there's no challenge in there. There is no challenge there. The challenge is now when it comes to the migration. The challenge is when you have to update the schema of your database. The challenge is now when you have to update. Mhm. Now when you have to update, exactly. Now when you have to update, or you want to, now when you have to update production. Mhm. Mhm. Holy hell, man. Holy hell. That's where the value of this shit it is, man. Completely, bro. That's where the value of this shit it is, bro. Totally, man. Totally. 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 Hmm. Holy shit, bro. This is just the basic query commands. So you're starting to see is the real challenge here. The real
I just want
challenge
to get
here.
everything back. That's what the star is for. So I can actually just say return star, which just means everything, right?
So you can see I did something in real time, which is Upsert. So I do a massive insert, I do a massive upsert of values. Okay, and if you any conflict, hey, I want you now to whatever conflict you find, especially by looking at the constraint, in this case, the title. Okay, so if the constraint or if the conflict is on the title, okay, uh, now you want to update this new value that you find. You want to now update is the value that you find with the new value. Okay, so such that value that you find, okay, and make the new one here. Or get the excluded value that you have, okay, and now updating that. Mhm. Holy Scheißen. Oh my god, this is not a game. This is not a voice game.
That was just when it gave me back everything in the order that I
This
asked
is
for,
not a
which means
voice
like
game,
change
bro.
the type. This one will give it back to you. I think it's
This is not a
generally
voice game, bro. Not at all, man.
in the order that you created it, but I don't think you're guaranteed. So let's do an
Oh my god. So you can do now is this. Holy hell. The important, yeah, man. The important of reflect of what you are doing, bro. That's to me is That to me is something that is needed for. Here, here is where these problems emerge. The problems, exactly. Here's where the problems emerge when it comes to, yeah, my friend, when it comes to underfetching and overfetching. You know, it's because your job or the vast majority of this company is like find a way to whatever query you are making, okay, optimize that. So only get the data that you want to send it back to the user or to send it back to the client. Oh, this is the true value here. And also help me to get this data as fast as possible by creating an index for that. Okay. All right. Oh my God. Here is where the value comes from. Here is where you say, okay, you know all of these things. Now I want you to make, I want you to find this correct. That's when you can get complicated with this. And that's why we're here is the true value, man. It's like, holy moly, I really love this. I really love it. The thing that I love here is that is the power it gives you when it comes to organize data and also when it comes to ask question to the data and get it fast. That's why the reason oh my god, I get it. 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 And I understand why, for example, some other indie hackers are actually using one database, not always, but one database uh, per table. Speed up the thing, speed up the thing. And if we have to actually update things, it's like I can do that pretty fast. Holy shit! Holy moly! So they don't complicate things like join query or yeah. Keep it simple, my friend. Keep it simple, bro. Holy f! I love it. I love it. I love it. I love it. I love it because this is now so things started to make sense of this completely as a way to say, oh no, okay, now that we know what we have to do with this kind of data. All right. Now we know what we have to do, especially as a way to provide value to the clients. So the vast majority of this the value that I'm going to provide to most of these clients is not only that I'm able to be able to build their user interface, or also to create the API, but also is to identify and optimize slow queries. And if I have to create an index, I will. All right. And by doing so, especially for their business use case, is like we optimize that. And the other thing is that, all right, let me now, okay, measure is the performance here. How many times this actually will, how many times, how many milliseconds or seconds this query took when you're doing your kind of step or when you want to query data. How many milliseconds this actually took. All right. All right. Okay. Move on, bro. Move on completely, man, because things are starting to make a lot of sense. You use is the exact. Okay. Interesting. Move on, bro.
Another insert
Move
that I want to
on,
show
bro.
you that you can delete multiple things with one query. So you can even copy and paste this one directly out because there's nothing really new here. Scroll down and copy
Is the elite?
this one.
Yeah.
So insert into ingredients, title image, not real one, delete.jpg, delete two. That's actually I think it's an error because that's not. That's not. Yep. Okay. So we did look up what this zero is. It's always going to be
It's
zero.
gonna be
So
zero.
in modern Postgres, which is I think post 9, this will always return zero. It used to be like an identifier for object IDs, which they don't use anymore. But there's enough stuff that depends on that zero being there or that number being there that they're kind of constricted by backwards compatibility for that always to be there.
Okay. Backwards compatibility, man. So okay. So the whole point of this is that he actually say, hey, uh-huh. Okay, this is how you can now explicitly tell to the SQL. But this is now by using SQL, you tell to the engine to run this. But in this case, the database management system. Hey, I want you to now update this and the column image you're gonna set with water metal. You can do that for all of the column image on this ingredient if that actually satisfies your condition, or when you find a particularity uh, element here, a unique element or an ID element. In this case, title with watermelon, you're gonna set the image like that. All right. If you want to return what was updated, try to do is this returning, or you can return is all of this. Okay. The asterisk means everything in this case. Let's add two row with identical image, which is this. Okay. What happened? Okay, it's actually updating here. Okay, so updating. So this is update, update, and then you say delete. The challenge here is that how you as a developer, how can you write queries that optimize is the insertion, the update, the deletion, as well as the lookup. That is your job, man. Okay. And also how you can create now tables that allow you to do this. So I don't think here there is a one particular way. This database will evolve and grow over time. There also, as a way you create new index, some of these older index will not going to be consumed, not going to be created, okay, and then you over time deprecate that, not using it, remove that. You save memory for that. That's where the role of this consultant actually comes handy. Yeah. So what happened when yeah what happened when we want to update something? Okay, like that. So what happened when we want to delete something? Okay, yeah, I think it's starting to make a lot of sense. First, let's let's add first let's add this. Mm-hmm. Yeah, so first let's add this uh, rows. Okay. Yeah,
So, in other words, ignore. The second number is the only one that you care about. So now I have two titled.
you'll always return is this. Uh, no, it didn't do that. Now it does. The returned is insert zero to two. The zero means backward compatibility. Ability. The zero means backward compatibility with, yep. The zero means backward compatibility with something called object ID, which is now deprecated from version 8 or 9. It's one of the reasons that you have to keep up the pace with this. All right. Very, very, very important. As a way to know is like, okay, what change? What change? Obsolete or rename feature? What change? What is the change log here? and they doing that at a rapid pace, bro. And then doing that at a rapid pace. Okay, fastware, feature matrix. But this is the about. Okay, upcoming events, past events, latest news, policy, feature matrix. Feature matrix. Oh my god. Feature matrix. What changes here in the backend? PG stat input and output metrics. Service statistics in shared memory. Holy hell. Unique nodes not distinct. Any value aggregated. Merge. Multi-row. Non-decimal integer literal. Regex count. Regex is, you can use this regex expression. System user. Underscore data definition language. Alter table set access method. Performance. Improve performance for sort exceeding working memory. Improve in window function performance. Incremental sort. Incremental sort for select distinct. Just-in-time compilation for expression. Low balancing for lib, PQ, PSQ. Parallel full and right join. Parallel hash join. Parallel join and aggregate. Parallel queries. Query pipeline. Table samples. JSON. Partition and inheritance. View materialized view. Replication. Exactly. Here we're not gonna see how to replicate databases. Now replication, deployment, backup, restoring data integrity. Data import and export, configuration management, and things like that. Channel binding from scratch authentication, security, transactions and visibility, cursors, save points, serialized table. That's interesting. This is the matrix. Okay, okay, it'll make sense. The matrix. Okay, cool, cool. I don't want to dive in too much in there. Just good, fine.
Where
Right.
I have two images where the image is delete.jpg, and I want to delete both of these with one query. So I can say delete from ingredients where image equals delete.jpg.
Yeah, pretty simple, pretty straightforward. So delete ingredient, delete ingredient, uh, delete from ingredients. Remember that this is it's like the Deutsch. It's very specific about what you have to say. It's very imperative. It's not declarative. Delete from ingredients, okay, where the title or where the image is equal to single quote delete dot jpg, right? And that'll be all.
let's just say I want to return all of them as well.
Okay, so for fun, I just want to returning all of them.
Again, this returning part's optional. It's only if you want to see what was actually deleted. So I had ID 100 and ID 101, title, image, type.
Exactly. What was deleted? Okay, so here in this case, as you can see here, and it indicated how many rows is actually deleted for that. Mm-hmm. The the returning the returning is optional. You can see here we can say, hey, this is the delete for the reference SQL command. You also have the PostgreSQL command. Look, not only is the SQL but also the SQL client application. Which is the interactive in terminal. Okay, even though you have a reference for this, for the client application and for the server application. So here we are looking is okay. Oh my god. Okay. Here we are doing is just for for the client application. It follows this architecture client server, and those who want to actually create server applications here is for that. Now this is the Postgres database server. Mm-hmm. So this contain is the client that is going to actually interact with the server, and it's the server who's going to be responsible for actually do the heavy lifting. Yeah. Oh my god. Oh my god. Okay. Okay. All right. All right. The returning is optional. You can see here the lead. Okay, the lead rows on a table. The lead rows truncate provide a faster mechanism to remove all rows from a table. This is one of the reasons why you should now look at the reference here. Truncate. Mm-hmm. Truncate. You also have something like truncate. Empty a table or set of table. Mm-hmm. Mm-hmm. Exactly. Since this is doesn't scan the table, it is faster. Furthermore, it reclaims this space immediately, rather than require a subsequent vacuum operation. This is most useful on large tables. Exactly. hmm But even though they actually recommend you is things that you can improve for that. That's very, very interesting. Even in the documentation for that, they tell you the update, as well as you look at the update here, update, Not always, not always, you know. Hmm. Again, actually, there is no need to memorize it, but it's to know when most of the time you need to find this because the whole idea is not memorize. The whole idea here is to understand what this what the things can do. Look at this, have the real life experience, and then you say, "Oh, okay, I know what I have to do." Mhm. Exactly. You're gonna update these values here where this condition in another table are being done. Okay. All right. Okay. 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 All right. On conflict, it is often preferable to use unique index reference rather than naming a constraint directly using the onConflict on constraint. Inference will continue to work correctly where the underlying index is replaced by another more or less equivalent index in the overlapping way. For example, when using create unique index concurrently before dropping the index being replaced. Alright. But again, the whole point of this is to learn these techniques, bro. That's the whole idea of why I'm looking at this.
So again, that default vegetable is coming from a constraint here from backslash the ingredients.
Which is a constraint that we've said that.
So this one has a default here of vegetable. If you didn't delete and recreate the table with me, you probably didn't get this default. In which case this first insert might have not worked. In which case we just have to go back and add not real, and then you have to add another type here of vegetable or meat or something like that. But if we did add the default constraint, then it would work. So just to kind of show you what that would look like. Okay.
What we mentioned about the constraint is because it's in this exactly. Uh, if you said that this constraint is not null, which is when you define your table here, when we define is the table here, create table here for this. Let me actually put this here. On But this is on altering that. Okay, when we alter the data here, exactly here, we're adding this constraint here. And then adding that constraint to that. When you're adding that constraint, it's like, okay, it'll make much more sense. Which is alter table. And then you have the create table here. You provide this constraint and then you alter that table as a way to adding is different operation, different transactions here, and then you add the constraint here that this is not null, and the default value will be vegetable. If you define that as, if you set the constraint, which is in our case, that's exactly what we did, with the type, okay, so the constraint type is can be not null, all right. There's another constraint here that we add this. Oh, that title, this is another constraint that we add that must be unique and must be not null, so you is required. That's what happened. Okay, and if you don't pass anything, we're gonna add this default value for that. So that makes a lot of, okay, that makes a lot of sense, totally.
Doesn't matter because we have no constraint on it for it to be valid.
But
Here you would have like,
mhm,
okay, set it again, and then again you can do the same.
which is exactly what you're doing here. So if you don't put any constraint to that, for example, in the case of type, uh, as default, you can say, hey, the type here is with this value here. Is that what? ¿Qué carajo? ¿Qué carajo? Okay. And then the other is this. Eh? Okay. Oh my God. So the idea here is that if you don't even, if you didn't update, if you didn't alter your table and add this constraint called type, not null, as a way to say, hey, this is required, and uh, then you don't define any default value, you will have to add this for that. But because this is actually something that is doesn't matter, we can if then delete from all of this. And it return us is the rows that we delete that.
Delete from and star. You can see here. Notice that we're inserting and deleting here. Here was 100 and 101. This is 102 and 103. It did not reuse those old IDs, right? It's just continuing to implement. So if you do something that unique identifier is gone through. I don't know about you, but like I feel like weird about deleting something that's like never going to come back. I don't know why I get like nostalgic for that. I don't know if nostalgia is the right word for it. Attached. I don't know. I probably should ask a therapist about that. Like the object permanence of unique identifiers in the universe. I feel bad.
Like the obvious permanence of unique identifiers in the universe.
I feel bad for people that never going through this today. Just therapy with Brian now. Anyway, so the delete front are really simple.
To me, this is something weird that you cannot reuse that element here. A note, side note, very important side note. It's like those IDs are not reused. You can see 67, 68. If you if you add more elements and delete them, for example, no, this particular observation is quite interesting and quite important to mention. It's like, for example, you have this, right? Oh, let me actually do it. So the IDs are not reuse. hmm The ID are not reused, which it might it might it might set yourself up to trouble. Yeah, because it's like since this is never released, you will have an ID so large and so big that this representation somewhat is like for how long you can represent this. Wouldn't it be better to have a unique ID and anytime you release you wouldn't it be better to have a unique ID and then anytime we release we delete that ID we actually can generate is a new ID from that as a way to reuse this ID because of course you can have infinite amount of number but again you have a memory constraint because for small app like this it's not a problem. Yeah, it's not a problem. Exactly. But for a small app like this, it's not a problem. But as your app scales vastly, you quickly you quickly realize that the of representation of numbers might not be an ideal candidate. But anyway, is in any case, this is a long-term thinking.
Updates, we just don't have a set there, right? All you're doing is just you're identifying where you're deleting from. You're giving it some where clause to say like delete these things. So you can kind of pick the thing that you delete, and then you can return them if you're interested in symbols. Otherwise, it'll just show you the number of delete to write. Let's talk about select.
Select paginating and using word clause. Okay. Select paginating and use square. Okay. There you got it. Okay. What about is select. Select paginating and using word clause. Mm-hmm. And using word clause. Let's get it.
I think I decided to go kind of out of order. Most people would learn select first, and then they learn how these other things that I've been teaching you. But I wanted to show you how to construct data and model data before we start looking at data, right? So,
Exactly. The approach here of looking first at how you can construct data and then how you can query.
most people would learn select first, and then they learn how these other things that I've been teaching you. But I wanted to show you how to construct data and model data before we start looking at data.
Exactly. How you can construct and model data before you can look up for data. It's a matter of preference. Makes sense.
So now we're actually going to start looking at the data. The most classic of them all is select star from whatever table you're looking at.
Mm-hmm.
This is going to give you literally everything back in the table. If you had 10,000 10,000 columns in your table, this will give you back 10,000 rows. You can see that my computer can even show them all at once. But that is what this did, right? So you can see everything that we've inserted in here. You can see it does skip some numbers here and there because that's stuff that we removed or deleted or something like that. But here we are. And we have a bunch of various different ingredients. So select, you're telling it what you want to, you're going to pull things out of the database. Select does not update anything. All it does is pull data out, just reads, right? Star is everything. Give me all of the columns from, you're asking from what table you want it to come from. You want it from the ingredients table. So that is it. What if I only need to see the title and the type? So notice there's no ID here and there's no image. I'm going to recommend that in general for your code, right? I'm talking about for like your JavaScript or Python or Ruby applications, you should specify what you want and don't just do star. Star is lazy.
Okay. Recommendations. So here is with select. Okay, select. This is how you pull data. This is how you pull out data from a table. Okay, and recommendations. Recommendations. That's right. Pull all the properties you need. Okay, pull all the properties you need for that query for optimization. For optimizations and payload. Okay, so for size, okay, and performance at the backend.
And it makes it more intentional that later when you come back to read your code, that you know I was asking for these specific things. You're being very intentional and kind of self-documenting in your code that you're asking for specific things rather than just give me everything. On a side benefit is slightly smaller payloads going back and forth between your application and your database. It's a little less processing of what's going in and out. Not really the point. It's so menial and small for the most part that you don't really care. The bigger advantage is that you're being more intentional with your code.
Okay, but that actually is not okay for readability. But that's actually not the big thing. The big thing is that you are more intentional intentional with your code. Okay. For readability. Readability. Readability.
So if my JavaScript application just needs a list of types and titles but does not need the images, don't do the star, just do select title and type. I'm asking that as your potential future coworker to help me out. What if I only want
Exactly. I am I am saying this to my future potential coworker. You know why? Destroy all, destroy all software. Hmm. Execute program. No boolean in SQLite. Nulling unique constraint. Deleting row, dropping tables, common. Referencing other tables, defaults, foreign key, SQL injection. On conflict do nothing. On conflict update, constraint analysis, simple joins, simple performance. Left and right joins, on and versus where. Join mistakes. Again, this is very, very basics. Hmm. Hmm. Uh-huh. This one. I'll pay for this, bro. Okay, so move on. Yep, move on. Move on.
10 things instead of everything, which is generally the case as well. If you have, I mean, can you imagine trying to do like select star from Facebook's user table or something like that? It would crash all the servers, right? Literally billions of rows. So
Exactly. But this is again for scalability. So imagine the vast majority of the companies they don't have that kind of problem. But it is important to actually do the exercise to know what might be the potential challenge you might face. What might be the potential challenge you might face? I'm saying this to my future potential coworker. So imagine you are at Facebook and you make a select to all of the you make a select you make a select all. You will you will crash the server. You will crash their servers. They are literal they are literally billions of records. Oh my goodness.
Add yourself a little limit there, and that'll give you back however many things that you asked for.
This is the
So I asked for
pagination.
10 things, so this will give me back only 10 things, right? You can see there are 10 rows.
So, okay, let's actually do the thing, the work. All right, let's do the work. So you say select, not from all. You say from here, ingredients, and you have to use the semicolon. Of course, you can see you're not going to actually print all of it, right? So, the hell is this? Oh, it crashed? What the hell? Alright, we're connected to that. That's interesting. But I can see anything here. The terminal died, literally. I don't know what the hell's wrong with here. It's like, literally, you die. What? It's like you die. Okay, no problem. So now let me getting access. So now I want you to tell Docker, which is this container of Postgres that I want to get access. Hey, I want you to execute this bash command. Execute the bash command with the username Postgres, which is something that is default. Okay, make it interactive. Okay, and the interactivity or the command that I want to run is on the name of the container, which is pg, and the command that I want you to run instead of the bash or in this bash is pg pg psql, the client, Postgres client. Hello, here we are. So it's like when we print, when we say, because actually backslash bash, oh my god, backslash d, here we are at Postgres, but I want us to now is look at where I am, query buffer reset, clear. I want to list. Okay, right now I am on the Postgres. I don't want to be in Postgres. In fact, I just want to change to database, which is to recipe getter. So template 0 and template 1 are the template 1 is the database that is used when is a template that I use to build a database. Okay, you can change, you can modify that. And template 0 is the database that Postgres using by default. All right, so if you for some reason uh, mess up the template 1, you can use a template 0 to create a new fresh template 1. Okay, but in our case, I want to get into the recipe getter, right? You're not connected to database recipe getter as you said a Postgres, and then I want to look is now at the data tables here, which is ingredients table and then the sequence here. And I want to now take a look at the list of database, list of relationship, okay. And then I want to now is do the select all of this from, for in this case is I want to take a closer look of the ingredients relationship, in this case table. All right, table public ingredient, this is how you can read of this. And if you want to now look at the data, Inside of this, you do is select uh, of exactly select all of this from. You shouldn't do this, especially if you're writing applications in Node or any other server-side language. Select from database. Okay. Select asterisk. Select all from the ingredients. You can also pass is a limit to that, which is 10, followed by the semicolon. And it tells, yeah, I got some spelling grammar here. Limit, and as you can see, I get is this. So, all right, this is a way how you can also can make some pagination here. Okay, slowly to see how you can make pagination. So, get this, then get this. All right. But the whole point of this is to only fetch the data that we need to. In our case, it can be the select here, but the columns that we want to get this. In this case, type and title. Say title, right? Title, and then say type. Okay, so get me is this. And this is interesting. Now it fetched like this. Oh, it fetch me is like okay. It fetch me like this. If I indicate this, okay, title and type. Interesting. If you indicate this, all right. Okay, okay. Holy moly. Mm-hmm. Okay. Remember, always indicate which column you need for, right? Okay. Which column you need for, which is in our case is this. All right.
It's a little bit better than a billion rows, right? So whenever you're doing selects, unless you really know that there's not going to be very many things, or unless you're intensely trying to get everything out of a database, you are basically always going to have a limit. So I have the first 10 things. What if I want the next 10 things? Well, offset 10. So that now gives me the next 10 things. And if I want the next things, offset 20. Right? So on and so forth. Eventually, it'll get to the last one. You can see you only have one in this. So even though I said limit 10, it's like I don't have 10 to give you, right? So you just get one. Now, what is a problem with this? Let's
You
say,
don't know.
like this is called pagination, right? I'm paging through my data. So a user queries my page like this, right? And they're seeing all of these ingredients. And then let's say we have a problem and we decide to delete black pepper, right? So I delete from database black pepper. They then ask for the second thing. All of these rows have now shifted up. So what happens? Pineapple is actually going to come into here, right? Because there's one less row here, because I asked for, and then the offset is precluding that, right? So basically, the user is never ever going to see pineapple, which is kind of weird, right? Now, if we're talking about ingredients, it's probably not the end of the world that they skipped an ingredient, right? I don't know, actually, it might be, but I would imagine in most cases it's probably okay. So this is the dangers of offset. And there's kind of a dual danger as well. The first of all is that if you're paging through it, you might miss things because things are being inserted and deleted and things like that. So, and actually a better way of doing this sort of pagination is to use these IDs, right? So rather than say offset 20, I can actually just give it a where ID is greater than 32. Or let's say, let's do it after 23. Right? Now if I delete something or something like that, we're anchoring on a row in the table rather than anchoring on some sort of offset. So if you're paging through data in your particular service, this is a better way. It's also way more performant. Because think about it. If you ask for, give me 100 rows and give me an offset of 1,000, your database has to go organize it, has to count 1,000, and then it gives you the next 100, right? If you keep doing that over and over and over again, it gets kind of expensive. Whereas if you're just saying, hey, give me everything bigger than this ID, it can just go right to that ID and then give you everything after that. It ends up being a lot more performant. So it's an optimization. You don't always have to do it. For our application that we do today, feel free to use offset. I just want you to know that that's a way better way of paging through data. Yeah.
So with Postgres, SQL databases that use generic IDs versus Mongo as this big hash.
Yeah, it's a good question. SQL databases almost always in general, they're just numbers. And these numbers might get to be, 100 million or a billion or something like that. Like, I imagine your checking account ID, like with your bank, is probably their primary key in their Oracle database, right? That's probably where they get that, right? Whereas something like Mongo or some other databases, they give you like objects. It's not really a concept here of that sort of thing in SQL. It's going to be a number.
It's more like UID or something.
Yeah, exactly. There's probably other ways of doing it, but it's almost always just an integer identifier. There are instances where you don't need an integer primary key, and I will show you that once we get into joins. Basically, you'll end up having some sort of like other thing be a primary key, and then you will not have a use for incrementing ID. But I can't think of a reason why I would like use a hash or something like that. That wouldn't make any sense to me. The ID would make a lot more sense. And the reason why I say that is like, you want to join things between tables and things like that. It's way easier to do with integers just mentally. And SQL is built for it, so there's no reason not to. Maybe stated a little bit differently from a Mongo perspective. Mongo, you really never want to do joins. This is not a Mongo course, so we're not going to get too much into it. But you don't have two collections and then try and join them together. If you're doing that, you're doing Mongo wrong for the most part. It's possible, it's expensive. SQL, you're going to do joins everywhere because SQL it's a relational database. There's an RDBMS, Relational Database Management System. RDBMS is what people call these style of databases. It's literally built into the name that these are supposed to be relational, which means those keys are supposed to line up, which means it makes sense for those to be integer numbers. We did limit, we did offset, and I kind of hinted at the next thing that we're going to talk about, which is where. So we can give it clauses where like I only want to select specific kinds of things. So
Mm-hmm. Our ID is between this segment.
if I say select ID title, wow, that was strangled, title, type from ingredients where, and I can say where type equals fruit. I put an extra comma there, extra comma. this where is just basically like, hey, make sure that this where clause holds true, right? We're giving it some sort of conditional to filter it on. There's a bunch of stuff you can do. I showed you. You can do like where you can do numbers, right? Where numbers greater than, greater than or equal. You can also say like, let's say we want to, select everything that's not a fruit. This little symbol right there, where it's just angle brackets put together, means not equal. So now I'm getting everything that's not a fruit, vegetables, meats, others, those kinds of things. I can do things like select star from ingredients, where ID is less than or equal to 10. You can also put and, right, or. We'll do and right now. ID is greater than 20, and then you limit 10, right? So this is going to give you everything. Oh, that's not what I wanted to do. Rather, I want to do this. Yeah, did I do that the wrong way? I did it the wrong way, didn't I? Some ingredients where ID is greater than or equal to 10 or less than or equal to 10. Like that. There we go.
Mm-hmm. Where the ID is greater than 10 and less than 10. Let's have to do that.
So this will now limit everything that I get between these numbers, right? So that's what these ends. Both these have to hold true. You can also put or in here. Right? So now this is giving me anything that's outside of those limits. Anyway, yeah, I have these all right in here. I don't know about you, but like I always have to think about the alligator and like which one's greater than or equal to it. I have to like check 5 times. But I got it right here. There we go. So here I'm asking for where the ID is
Less
outside of the range of 10 to 20.
less than 10 or ID is greater than 10 outside of the range of 10 and 20.
Right?
Mm-hmm.
Inclusive of those, right? So you can see this goes 1, 2, 3, 4,
That particular
5,
logic
6,
here
7,
is important.
8, 10, and then it skips everything 10 to 20 because that's what this or does. And
It
then
excludes that exactly. And this is where the value of a lot of the
so
things here.
there's a bunch of other like conditions you can do that we're gonna like look at
This is
fuzzy
filtering.
text search and some other things like that here in a little bit. But just know that like it's not just like equals or less than equals. There are others as well. Last one I wanted to show you here is select star from ingredients, where let's say limit 10 here for just a second. By default, these are generally going to be ordered by ID because that's going to be generally the order that they were inserted into. But just know, according to the SQL spec, it's not required to give you back anything in any order, right? Generally, it's going to give it back to you in the order of insertion, but that's actually not required, and you probably shouldn't rely on it in your application. If you care about order, you need to provide a order by. So in this case, order by ID would get you that same thing, but let's say you wanted it in descending order. So now it's 33, 32, 31, right? It's giving you back in reverse order. That's what that desk means, descending, right? Just so you know, you can put ask in there, ascending, but that's actually just the default. It's just optional if that's important to you to be specific. But you can also put order by title in there, right? So now it's going to give it back to you in alphabetical order. Likewise, order by title, descending, it'll give you back watermelon, tomato, sugar, strawberry. In other words, if you care about order, you should provide order because While Postgres is generally consistent, it doesn't have to be. Okay, questions about order by? Yeah, Dustin.
Do you have any preference between CLI or some kind of SQL client when working with an SQL database?
It's a good question. Do I prefer using the command line, or do I use something like, the other option would be pgadmin, which we will see in the second half of the course. I almost always use PSQL because I just always have. It's what I learned on. It's what I continue doing. Um, it's not a good reason, but it's just my reason. There's other people that grew up using things like pgadmin or PHP myadmin for like MySQL. Also very common, and I think JetBrains is like a really good SQL client. I can't remember what it's called. There's like VS Code or VS extensions for querying databases that are like visual. I like writing queries and seeing the results, so this is what I do. But sometimes it's really useful to take that data and like make graphs out of it and stuff like that. Things like a client, some sort of GUI can help with that.
GUI. Mm-hmm. Pure Go, lightweight, GUI is editable, support different kind of database, MySQL, SQLite. GUI, work in progress. Mm, GUI. Okay.
You see, this doesn't help you with graphs, right? So you can also generate like CSVs and put that in Excel, and then Excel can generate graphs for you. I've done that a bunch,
Mm.
but I'm just used to doing it.
Alright, so that'll be all for this video. Take care. Bye bye. Okay, okay.